Good morning, I'm Consilvio from the University of Genoa. In this presentation, I will provide some detail about the decision support platform for the optimization of maintenance planning that we developed in the OMICRON project. So the decision support system is specific for road maintenance planning and is able to provide condition analysis and predictive maintenance prioritization, optimize the maintenance plan, also taking into account the traffic data and the traffic condition in the network. The system was integrated in the OMICRON platform and tested with real data. Regarding the main objectives, so we need to consider a road network, and we have to book some road possession and manage work zones. So the maintenance plan has to consider condition aspects about asset status, asset importance, and deadline for maintenance execution, but at the same time also operational aspects such as the impact on traffic of the work zones, the configuration of the work zones, and the number of active work zones present in the network at the same time. This is the diagram that represents the information flow and how the data that we collect were analyzed. So we consider four main types of data: infrastructure monitoring data, pavements parameters, traffic data, and maintenance data. The red square highlights the information flows regarding the condition analysis. So we use the infrastructure monitoring data for the structural health monitoring of bridges and pavement parameters to analyze pavement condition and road sectioning. The traffic data and maintenance data are instead used within the maintenance planning process. In particular, traffic data are analyzed through simulation technique, and the results of the analysis are then used as input in the planning. As you can see, the link highlighted by the arrows. The maintenance data are analyzed again to be used both by the simulation in terms of work zones, characteristic, and configuration, and also by the planning. So if we consider traffic simulation, we can simulate in the tool different type of work zone configuration. In particular, we consider the single lane closure in a 2 lanes carriageway and the traffic deviation due to the complete carriageway closure. And in this using the simulation software, we can model the detail about the work zones and the deviation of the traffic. The output that we get, basically, we consider as main parameters the queue length generated by the presence of the work zones, and also the travel time delay due to the work zones present, according to the specific condition of the traffic in that period, in that days of the year. We have also to consider the traffic flow fluctuations. So we have, if we consider the average traffic flow in the different days of the month, we will have some traffic peaks that we would like to avoid. So basically in the planning, we would like to plan work zones in the off-peak days, avoiding the traffic peak days. Regarding the integration of this information in the maintenance planning, as you can see in the diagram, so the impact on traffic is used in the planning, and also the data analysis information about the pavement and bridge status and the importance of the asset. What we get as output, here's the maintenance plan. so the planning of the work zones and the maintenance activity. We will have also different scenarios and alternatives of maintenance plan that can be chosen by the infrastructure manager, and also the performance indicator that are related to the specific plan and scenario. If we consider the optimization model, so we have a multi-criteria optimization. We consider different main objectives, in particular priority, degradation, the average queue length during maintenance, the average travel time delays, and also traffic limitation that we may have before maintenance execution, in particular for critical bridge condition. The decision variables of what we can get as output is an assignment of work zones to time interval, and also a suggestion of configuration among the alternatives that are defined by regulation, of course. Regarding the integration with the pavement and bridge analysis that was described by Paola, so one important step is this integration. We need to consider the output of the pavement condition analysis. In particular, we consider a global performance indicator that can define the status of the road segment in excellent, good, or critical condition. And we have also to consider the different granularity that we get from the analysis of the pavement condition, that this is a very detailed granularity, and instead the granularity and the dimension that instead we need to define the work zones. This is why we developed algorithm for the work zone suggestion length that provide a definition of work zones according to homogeneous status and location of the road segment. Considering instead bridges, we take into account the parameters about the loss of stiffness, and we define three different main conditions of minimal degradation, low degradation, and critical degradation. And according to this condition, we have also the effect that we have on the traffic, so the closure of one lane or the complete closure of the bridge. And this traffic limitation due to bridge degradation are also applied before the maintenance execution. Regarding the platform, so as you can see in this image, so we can show to the infrastructure manager the maintenance plan as a Gantt chart with different colors that highlight the type of work zone, if it is a lane closure or a traffic deviation. We can see in the map also the detail about the work zones, such as work zone ID, the starting and final kilometric point, the direction, and the position. We can select different scenarios, so the alternatives in the plan are related to the importance that the infrastructure manager assign to traffic-based factors and condition-based factor, or the same importance level for all the both the factors. In this way, we can give to the infrastructure manager the possibility also to choose the best solution according to his vision. Regarding the second important information that we have in our interface is the traffic impact and the average daily traffic volume that we have in the different days of the month in the considered section of the highway, classified here in high, medium, or low impact. And this is also important information for the infrastructure manager to have a global vision and idea about the condition of the traffic. And we have, of course, also the visualization of the main KPIs in a bar chart. As I mentioned, we have the priority of the intervention, so which is the impact of postponing, for example, an activity with a high priority, the degradation level. So we would like to prioritize, of course, the maintenance activity in case of asset with the high degradation level, the queue length and the delay caused by the presence of the work zones, so other traffic limitation that we mentioned before due to the degradation of the asset, and the traffic volume that we are impacting. And finally, we have also the detail about the work zones in visualized in a table, in which we have also additional information such as the type of the maintenance intervention that we have to perform, that we suggest, the starting and ending time suggested for the execution, the suggested configuration, and we can visualize, of course, in the map, the correspondent work zones with different colors according to the configuration. So in conclusion, the main benefits that we can have are the reduction of major maintenance interventions, so when maintaining the asset before reaching high degradation, the reduction in traffic disruption, planning the work zones during off-peak periods, a reduction in the regular maintenance cost, a reduction of accident due to bad condition of the road pavement, the increase of network availability, both from the point of view of traffic disruption due to accident, but also due to the maintenance, the execution, and the work zones presence. Regarding the key message and element, so we developed a maintenance planning decision support tool. We consider the integration of the asset condition evaluation in the maintenance planning. We integrate information about the traffic condition to be considered also in the planning of maintenance activity, and all the results are integrated within the OMICRON intelligent platform. So our main goal is promoting the shift towards user-oriented predictive maintenance strategy, so minimizing as much as possible the impact on the final users of the highway network. Thank you.